Dear students, welcome back to our channel. In previously I discussed the oscillation topic. In this class today I would like to discuss the work energy power. Work energy power, very important concept. This one is very important concept, and in this chapter main concept is law of conservation of energy. To get good marks in IP examination and also good marks gain in NEET or JEE advanced syllabus. First of all is law of conservation of energy. Law of conservation of energy. In case of law of conservation of energy, and in case of freely falling of the body, in case of freely falling of the body, let's start. First one is, let's start statement. Main one is energy neither be created nor be destroyed. Statement is first, energy neither be created nor be destroyed. It can be transformed from one form to another form, but total mechanical energy remains constant. Here mechanical energy is the sum of potential energy and kinetic energy. Mechanical energy represents E. E equals to potential energy plus kinetic energy. The sum of total energy is the sum of potential energy and kinetic energy. That is equals to E. E equal to constant. This one is mechanical energy, and again E equal to the sum of potential energy and kinetic energy. Change in kinetic energy, mathematically change in kinetic energy. Delta E equal to delta U plus delta K, that equals to 0. Finally delta E equal to 0. Change in derivative function of energy equal to 0. Finally energy equals to constant. Mechanical energy is constant. This energy E equal to constant. Mechanical energy is constant. Conservation of energy, this one is conservation of energy statement. And by the proof of conservation of energy, we go to the discuss the when a body of mass m, it is freely falling the downward state. Proof of mainly conservation of energy is subdivided into 3 points. First one is A, say total energy calculated. Second one is B, total energy calculated. Third one C is total energy calculated at a point A. For the more information of diagram about here, first one is at a point A point. Second one is B point. Third one is C point. This is ground level state available here, body. And when a body of mass m, this ball or body of mass m, it is placed some certain height from the ground. Initial velocity of the body is taken to be 0, and center of the gravity is always acting downwards at point B, at point C. The distance between, consider the distance between A and C is height, to measure some height h. Consider a body of mass m. It is freely falling the ground through a certain height from the ground level. This one is ground level. Ground level. This one is ground level. Center point A. This one is center point B. This one is center point C. Center point C. Velocity at point A. Velocity at point B. Velocity at point C. Now the distance between A and C is height h. H is the distance between A and C. Body travelled A to B. Some displacement is x. Body travelled A to B. Some displacement is x. And again, this body, to maintain some height h, potential energy is increases at highest point by the, I think, observe that phenomena is potential energy is increases and kinetic energy is decreases. That body travelled A to B, B to C, A to B, B to C. At reaches the ground, height becomes 0. Height becomes 0, velocity 0. And again, at B point, initial velocity 0. At C point, initial velocity 0. So, remaining displacement A to B is x. Remaining displacement is, total height is h. Body distance travelled A to B is x. Remaining distance BC is measures h minus x. H minus x. This one is h. This one is x. Subtract total height to minimum displacement is, remaining displacement is h minus x. This one is h minus x. Now coming to the point, yesterday last class we have to told the main displacement x is and x or y are displacement, x or y displacement. Proof of law of conservation of energy, at 3 states total energy are equal. To substitute or to prove that total energy at a point, total at a point A, total energy calculated. Total energy is remains the sum of potential energy and kinetic energy. To calculate that point A, B, C, total energy at point A, at first one is at point, first one is at point A, at point A. At A point, initial velocity u becomes 0. Initial velocity u equals to 0. Initial velocity u equal to 0. Initial velocity, acceleration due to gravity at A point, A equal to plus g. G is always downwards. G is downwards. A equal to plus g. Plus g. Plus means in the vector component of 2D plane motion. Plane motion, A equal to plus g. Acceleration due to gravity plus g. Initial velocity u becomes 0. And displacement A to B is x. Here potential energy calculated. Now potential energy is mg into height. Mg into height. Height is, total height is h from the ground level to at a point A. Body freely falling at highest point A to C. Distance is h. This distance is measures total height. Height is h. So height value is substitute in this formulate. Therefore potential energy P equals to mg into height h. And again kinetic energy. Now we calculate kinetic energy. Kinetic energy K equal to of m u square or v square, remaining factor. It can be used as u or v. In this point u becomes 0. This value is substitute in this equation of m 0 square. Finally kinetic energy equals to 0. total energy at point A. Therefore, total energy at point A equals to the sum of potential energy U plus kinetic energy K, whereas replaced P plus Ke or U plus Ke. Total energy, potential energy is taken to be mgh plus kinetic energy becomes 0. Therefore, total energy at A point, this total energy is finally mgh. Total energy at A point is mgh, small h. This one is total energy at point A. Here this point, total energy is measures mgh. And second one is at point A. First one is at point A. Second one is at point B. At point B. Now calculate the total energy at point B. Total energy at point B. Again, initial velocity u equal to 0 and acceleration due to gravity a equal to plus g. Height, calculate the height is taken to be height at point B. Height at point B is measures from ground level to at point B. Height measures h minus x. Height is h minus x. And again acceleration due to gravity. Velocity at point B, Vb. Velocity at point V equals to Vb. This one, velocity at point V equals to Vb. Now calculate the potential energy. P equal to mg into height. And second one is potential energy P equals to mg into, whether it is h is replaced by h minus x. Finally, potential energy is substitute and multiply with mg. mgh minus mgx. This one is potential energy. And again potential energy. Now calculate the kinetic energy of a body or kinetic energy of ball. Kinetic energy K equals to of m Vb square. To measure point B, Vb square. Kinetic energy K equal to of m Vb square. Finally, of m Vb square. Vb square is the at point B velocity. Now calculate the Vb from equation of motion. From equation V square minus U square equal to 2as. V means velocity at B point Vb square, and again U means 0 at B point, initial velocity 0 square V square minus U square 0, that equal to 2. A means g. S means distance travelled. S means distance travelled. S means S equal to x. Here S means distance travelled from A to B, that is the distance, the displacement is x. Finally, Vb square equal to 2gx. Now define of kinetic energy. K equal to of m Vb square. This value Vb square value 2gx is substitute in this equation of m Vb square. 2gx, 2 get cancelled, remaining is mgx. This one is kinetic energy. This one is potential energy. Total energy at point B equal to the sum of potential energy and kinetic energy. The sum of potential energy and kinetic energy. KE, this one is KE, the sum of potential energy and kinetic energy. Total energy equal to potential energy. Potential energy measures mgh minus mgx plus sum of the potential energy and kinetic energy plus kinetic energy equal to mgx. This one negative height, this one is positive height, mgx minus mgx plus mgx get cancelled. Total energy at point B equal to mgh. This one is total energy. This is equation number 2. First one is total energy at A point is mgh. This one is at point A mgh. At point B, calculating the potential energy at point B, total energy equals to mgh. And again third point, and remaining point is C. C point is ground level. At ground level, displacement and distance, height becomes taken to be 0. Displacement at point A, this equation 1. At point B, this equation number 2. At point C, 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 in the similar equations, at C point, initial velocity u equals to 0 and acceleration due to gravity a equals to plus g, and height is taken to be h equals to 0, and distance travelled from A point to C point is distance travelled from A point to C, distance or displacement, distance travelled A to C, S equals to total distance A to C equal to height h. Now calculate the potential energy is mg into height h. This is the general equation of potential energy. Mg into height becomes taken to be 0, that equal to total 0. Potential energy equal to 0. And again this one potential energy equals to 0. And again kinetic energy at C point is of mvc square. Of mvc square. Again vc square is the velocity at point C. From equation, again in the before point B point, similar way of method calculating. From equation v square minus u square equal to 2as. V point velocity at C point velocity, v means this point velocity, C point velocity, vc square minus u becomes 0, u is always 0 square. In case of freely falling of the body, initial velocity 0. 2, a means plus g, s means distance h, vc square equals to 2gh, vc square equal to 2gh. This value is substitute kinetic energy equation. This value vc square value is substitute above equation. Kinetic energy ke equals to of m vc square to get 2gh. Again 2 cancel, remaining factor is mgh. Kinetic energy is mgh. And this one at point A, kinetic energy kinetic energy equal to mgh at point C. Total energy at point C equals to sum of potential energy P plus kinetic energy Ke. Potential energy is always P equals to 0 plus kinetic energy is define this function value mgh. Finally total energy at point C equals to mgh. Finally total energy at C point equals to mgh. This is equation number 3. First equation, total energy at A point is mgh. Again total energy at B point is mgh. Total energy at C point is mgh. At above 3 equations, from equations 1 and 2 and 3, from equations 1, 2 and 3, total energy are equal. From equation 1, 2, 3, total energy at A point equal to total energy at B point equal to total energy at C point are equal. So total energy remains constant. Hence law of conservation of energy is proved. In this phenomena, energy, this energy at every state of system is equals. So hence law of conservation of energy is proved. Hence conservation of energy is proved. Energy is proved. Thank you for watching this video. Please subscribe to it. For more updated videos are available here. Thank you.